Hello all, in this particular video we'll be learning about the concept of code converter. This is the 7th experiment in your lab part B. Before we start this experiment, I would like to acknowledge these students, Naveen and his team, for preparing this beautiful chart for the purpose of explanation. First we shall try to see how to convert your binary code to your gray code. And in the next part, we'll be looking upon how to convert your gray code to your binary code. Before I go ahead with this whole concept, I need to tell what is code converter is. See, code converter is a concept which is used when we want to send any information which has to be encoded. We use the concept of encoders and decoders. So this is where we use the concept of code converters. So let's see how to convert your binary code to gray code and also your gray code to binary code. Let's take up an example. Let us see. I want to convert a binary code to your gray code. Okay. We'll take a binary code. Let us say 0011. Okay, how to convert this to your gray code? So this is done. This is your MSB. This is your LSB. So that is your least significant bit and this is your most significant bit. Your MSB remains same. That is for your gray code. 0 remains same. The second bit will be XOR of these two. 0, 0 is 0. Next 0, 1 is 1, 1, 1 is 0. Okay. So this is how you convert your binary code to your gray code. The operation involved here is your XOR operation. Okay. So now let us take an example for your gray to binary code. Gray to binary. Let us take a gray code. For example, we'll take an example of 0110. In this, how to convert to your gray code is my question. So your MSB bit remains same as the previous thing. Your second bit will be addition of these two. So 0 plus 1 is 1. 1 plus 1 is 0. 1 carry will neglect the carry. 0 plus 0 is 0. So the binary code of 0110 is 0100. Okay. So this is how we convert your binary to gray and gray to binary. Let's go with the lab experiment part now. The aim of the experiment is to design and implement a binary code to gray code converter. Okay. So first we'll take up the binary to gray code converter. There are various steps which is involved over there. First step, there are mainly 3 steps. When you are converting any code that has given binary code to gray code, in the first step, the MSB bit will remain same. In the second step, you will XOR the first and second bit of your binary. So the resultant will be the gray code. Second, XOR with these two, the resultant will be this. XOR with these two, the resultant will be this. Okay. So I have taken 4 variables A, B, C, D. The output will be again 4 bits. G0, G1, G2, G3. That is my gray code. If there are 4 possible inputs, possible combinations of inputs are 16 possible combinations starting from 0, 0 to 1, 1, 1, 1. Let's take this first 0. So how to convert this into gray code? Your 0 remains same. 0 XOR 0 is 0. 0 XOR 0 is 0. 0 XOR 0 is 0. Let's take some other example. We'll consider this 1 0 1 1. So 1 remains same. 1 XOR 0 is 1. 0 XOR 1 is 1. 1 XOR 1 is 0. So this is how you convert your binary number to your gray code. After doing this, we'll be considering each bit here. So we have G0, G1, G2, G3. We have to draw the circuit. Before we draw the circuit, we need to construct your K-map and reduce the equation. So here G0, what are all the min terms which I am having? I will write down all the min terms here. So for G0 here I am having 1. What is the number associated with this particular one? Binary number. 0 0 0 1. It is mean it is 1. So your G0 value will be, the first min term will be 1. Same here. For the second one, your value will be 0 0 1 0. It means it is 2. So your second min term will be 2. Likewise, I will be writing all the min terms for G0 here. So if I write all the min terms for G0, I am having the value of 1, 2, 5, 6, 9, 10, 13 and 14. I'll plot the K-map for the given variables, min terms, so that I'll be getting the answer C bar D plus CD bar, which results in C XOR D. That is the answer for G0. Similarly, I will take for G1. So if I consider G1 here, so I am getting the min terms 2, 3, 4, 5, 10, 11, 12, 13. If I plot the K-map for this, I get 2 quads here, which results in BC bar plus B bar C, which is nothing but B XOR C. That is your G1. Similarly, I'll do it for G2. Min terms I have got is this. If I plot for the same K-map, I'll be getting A bar B plus AB bar. The answer is A XOR B. Similarly, I'll plot for G3. My min terms are this. And then if I plot for K-map, my answer is A. Soon after getting the answer for G0, G1, G2 and G3, it is easy for me to plot the circuit diagram. So the circuit goes like this. So answer for G0 is C XOR D, G1 is B XOR C, G2 is A XOR B, G3 is A. The inputs are here. Writing the pin numbers is very easy. 1, 2 is your input, 3 is my output, 4, 5 is input, 6 is output, 9, 10 is input, 8 is my output. The IC number is 7486, which is your 2 input XOR gate. This is all about your binary to gray code converter. Now let us see how do we convert your gray to binary code. As we took the example, let's go dive into deep with the same example here. I have taken the gray code from the previous table which I have obtained. The same gray code I have taken and copied it here. Okay. So for this gray code, I want to convert it into binary code. Let's see how do we convert it. Let's take an example of this particular gray code. It is 0 0 1 0. What is my MSB? So 0 remains same. Next, 0 plus 0 is 0. 1 plus 0 is 1. Next, 0 plus 1 is 1. Okay. Let's take another example. 1 0 1 0. So your MSB remains same. 1 remains same. Your second bit will be added with the result of first. 0 plus 1 is 1. 1 plus 1 is 0. 0 plus 0 is 0. So after calculating this, you will be getting your binary numbers. That is your B0, B1, B2 and B3. There is an important point which you must look here. As soon as you see, we want to write them in terms of B0, B1, B2, B3 now. I'll start writing them in terms for B0 here. See, for B0 here I am having 1. So for corresponding 1, what is the number associated with it? So it is 0, 0, 0, 1. So my first minterm for B0 is 1. Next, let us say I have taken this one. What is the number associated with this? It is 0, 1, 1, 1. 1, 1, 1 is 7. Okay. So my third, I have 7 as my minterm. So likewise, I'll plot for B0, B1, B2 and B3. After considering the minterms, these are all the minterms which I have got for B0, B1, B2 and B3. Let us consider B0 now. I'll take only B0. If I consider B0 here, as you could see, B0 is having the minterms 1, 2, 4, 7, 13, 14, 11 and 8. It is not possible, if you look at the K-map, it is not possible to map here. I'll go for Boolean value simplification. So how to do your Boolean value simplification? It's very much easy. I represent all the minterms with your Boolean values. So one is represented as, since it is a 4 variable Boolean, I can represent one as A bar, B bar, C bar, D. 2 as A bar, B bar, C, D. 4 as A bar, B, C bar, D bar. Likewise, I will be replacing this whole minterms with your Boolean values. Now I further simplify this by taking A bar, B bar as common. The remaining terms with these two will be C bar, D plus C, D bar. Next, I have taken A bar, B as common with these two, so that I am getting C bar, D bar plus C, D. Next, I have taken A bar, B as common in this and this, so that I have got C bar, D plus C, D. Next, I have taken A, B as common, so that I'll be having C bar, D and C, D bar. It is C, D bar. Now, A bar, B bar into, this will become C XOR D. A bar, B into C XOR D whole bar, that is C XOR D, plus AB bar into C XOR D plus AB into C XOR D. Now, let us assume that C XOR D as my X, so that it will be A bar, B bar into X, A bar, B X bar plus A, B bar, X bar plus AB X. Now, I can take X as common with these two terms here. If I take X as common, it will be AB plus A bar, B bar plus X bar as common here. It will be A bar, B plus AB bar, which will result in X XOR A XOR B. What is the value of X here? It is C XOR D, which will result in A XOR B XOR C XOR D. So this is the simplification for your B0. So this is the one element which I have got. Let's go with the element of B1 here. This is what the elements which you have for B1. Draw the K-map for your B1 here. So if I draw the K-map for B1, I have got the answer A XOR B XOR C. Similarly, I'll draw for B2. I have got A XOR B. I'll draw for B3. If From B3 I have got A as my answer. If you have got the answer for all B0, B1, B2 and B3, it is easy for us to draw the final stage circuit. So your B0 answer is A XOR B XOR C XOR D. So this is your A XOR B XOR C XOR D. B1 I am having A XOR B XOR C. Here I am having A XOR B. Here I am having A. So the IC which I am using here is 7486. So the pin numbers is as usual. Input is 1, 2, output is 3. 4, 5 is input, 6 is output. 9, 10 are input and 8 are output. This is the circuit for gray to binary code converter. So this is all about your code converter. In this particular video, we have studied about how to convert numbers from binary to gray and also from gray to binary. Thank you all.